Okay. So here is a Prescott-Townsend economy. So that's the basic environment. So you have agents. The agent would like to consume, and they need to work. Oh, just to make it clear, sorry. This is kind of give them this utility. Okay, higher A is going to be lower utility because otherwise there's no problem, right? I mean, if they love to work, let them work. Everything is fine. But no, they don't want to take good action. They want to take bad action because taking bad action gives them more utility. But taking bad action is bad because give them low output.
Can you give me an example of a contract here? So is it like an insurance that I'm buying from the market?
Yes.
Okay.
So here is going to be insurance contract. So we're going to focus on insurance. So agent is going to have concave utility, at least on consumption. So they would like to smooth consumption. But to smooth consumption perfectly or first best, that's not going to be incentive compatible. So because they're not going to work hard because they know that, I mean, they don't need to work hard, they get good consumption anyway. So that's why the contract has to kind of adjust to that. Good. So the key assumption in Prescott-Townsend that we're going to deal with today is there's no spot retrading. So that means once you sign a contract, tell you you're going to get 10 units of good one and 20 units of good two. Once that's done, once that's executed, that's it. Then you consume that. You consume 10 and 20. Okay, and we're going to introduce later spot market so that you can go to the market and say, no, I don't want this 10 and 20. I want 15, 15, for example. Something like that. Okay, that's going to cause a problem. So here's a technical term a little bit that the commodity space that we consider here is on A, C, and Q. So that means the thing that we worry about is going to be what action you're going to take, what consumption you're going to have, and what's realized output you're going to be. So the trick of Prescott and Townsend is going to be like, well, first they're going to use lottery to deal with non-convexity that come from private information. And secondly, they're going to put the technology or the production into the lottery too. Okay? Therefore, they don't have to have separate, like, oh, okay, I have to write contract on A and C and then deal with output later. So they put everything together, so this is kind of contingent contract by itself. So it says that if output is Q, then I get this C. Okay, in general, C is going to be a function of Q. Okay, but here we make it general. We write it in general. When we put in computer, just try to solve for this one. There's going to be a whole bunch of this. There's going to be a whole grids of A, whole grid of C, and whole grid of Q. Okay, you just need to look for where you put the mass on this grid. Okay, that's how we compute it. And this is, we're going to interpret this as the probability of getting a recommendation of action A, receiving compensation C. Okay, now I'm talking about compensation, but sometimes we can call it as consumption. Well, at least in this case, this compensation C is going to be exactly as consumption, because after you get this, you have no way to go. You have to eat it. And this, when the output is realized, is Q. Okay, that's our lottery. So that's the contract that we're going to trade. We're going to sign a contract and say, you should take this action, and then you're going to get this output if your output, or you're going to get this consumption if your output is Q. Okay, that's the contract. And you trade that. And okay, so here is an important constraint. First, is very standard that since X is a lottery or is a probability, so it has to sum equal to 1. So you cannot, you put mass, but you have to put total of the mass that you put on the grid has to be 1, right? Okay. And then this is a tricky one, is that since the Q is in the X by itself, so once we put the technology, the production technology in the lottery itself, we have to make sure that the lottery is not like something totally different from the production. Okay, the output that you can get through the lotteries must also be the one that comes from the production F that we have. That's what we call mother nature constraint. I mean, it's like, because this comes from the nature that tell you this is all you're going to get if you take A. Okay, then whatever you specify, the contract has to satisfy that. Otherwise, you have to find something that you not produce to give to the guy or take it away or something. Okay, so that has to be done. And then also, because it's private information, we have to have incentive compatibility constraint, or we're going to call it IC constraint, such that tell you that taking action A, okay? So here's a contract tell you to take A, and now you take action A, okay? It's better than when the contract tell you A, but you take action A prime. So that is a deviation. So that means you're going to take A because A gives you a better utility. Okay, and here's a likelihood ratio because when you take A prime, output distribution is going to be different. So that's why you have to put this likelihood ratio in. Okay, the duration is in Prescott-Townsend. You can see it. It's nice to see, I think. Okay, and the idea of consumption possibility set, which we call it X, we put PT here just to represent Prescott and Townsend, defined by these three constraints. It's going to be the same everywhere, so that's why I tell you now. But even when I have retrading, it's going to come from this kind of three constraints as well, but this may look different, that's all. Okay? This is what we call consumption possibility set. So that means you can choose any X that you want as long as it satisfies these three constraints. Okay? This has to hold, and then you can choose that X. If it violates this X, you cannot choose. Is that okay? So that's going to be the key because we're going to talk about externality through that. And then let me tell you quickly about Prescott-Townsend equilibrium. Now we talk about market. Before I just constraint, right? Just what you can choose. But now, of course, you can choose anything that is in the X that I said. But since every X has a price, you have to make sure that you have enough money to buy them. Here is a bit strange, but I mean, it's just because we assume that everybody has zero endowment. So the income side is zero. This side has to be less than or equal to zero. Well, you may say, how come? Well, because this P can be negative.
Where did you compute the price?
I'm going to compute it through the planning problem. I showed you soon.
Okay.
But maybe what you asked, so here it can be negative. I mean, the idea is because this contract is actually insurance contracts, right? Insurance means sometimes you're going to give, sometimes you're going to get. The one that you give is going to have positive price. The one that you get is going to have, let me see. No, sorry. The one that you give is going to have negative price. The one that you get is going to have positive price for you. Somehow you have to do both, right? Even when you buy the car insurance, it's like that. When nothing happens, you kind of give. When something happens, you kind of get. So we kind of put that into the price. This kind of take care of that. Okay? That's why the price can be negative here. There's no reason to constrain the price to be positive. And then we need brokers because here imagine that agent kind of choose lottery. To the agent is kind of choose something that's random. You choose something that you're not sure what's going to happen, but there's some probability here, probability there. Everybody do the same. Now I'm the broker dealers. Okay? We can assume that there's no loss of general to assume there's only one. Okay? This guy is going to say, well, I know that fraction of this guy will choose this, fraction of this guy will choose this. So I'm going to supply this amount and supply this amount at this price. Okay? I'm going to want to supply this given that I want to maximize profit. This broker dealer is kind of principle somehow. Okay? But it's more like in the sense of competitive market. They also maximize their profit. Subject to the price though. They don't care about how you're going to choose the contract. It's not like principal agent where they write everything at the same time, right? So here the dealer also look at the price and say, oh, price $10. I want to supply 1 million contract. Okay? And they do that in such a way that though, oops, here should be Y, sorry. This guy doesn't care about X, okay? This guy care about only thing they do is Y. So they're going to choose how much they're going to supply the contract, which is Y. Given that whatever they supply, they have to make sure that the consumption that they're going to give to the guy is not more than what the guy going to produce in total. Because otherwise they have to find a good from somewhere else, which is not possible in this world because the world is closed. Okay, everything that they can have is just from the production. Okay, so that's why this is kind of resource constraint. The dealer has to make sure that that happens. And then we have market clearing. So the price is going to be the price such that whatever if you want to buy 10 units here, the supplier supply exactly 10 units. That's a market clearing. That happens, the price can move, right? The price is going to move so that happens.